Hello, welcome to this chapter on the housing of broiler chickens. It's part of the module on poultry welfare and behavior, and it's actually the sixth chapter that we will be discussing. I will touch upon a couple of topics regarding the housing of broiler chickens, and especially topics then that also relate to their welfare. So I'll talk very briefly about conventional housing systems for broilers, and then a novel housing system, the patio system. Shortly, something about enrichment for broilers, and then also a chapter on the link between the litter and the litter quality and contact dermatitis, and then something about lighting systems for broiler houses. So let's talk about conventional housing systems for broilers. We did a survey of broiler farms in Flanders about 10 years ago. And in order to get some data on the commercial housing systems, at least in my country, and you can see that the group sizes on average were about 20,000 animals housed in the same barn, and they were slaughtered on average on 42 days when they were about 2.4 kilograms of body weight. The mortality, we divided up into unassisted and assisted mortality. The unassisted mortality was about 3.2%, and the assisted mortality about 1.1%. But as you can see, there's also a lot of variation, so the range between the different farmers is quite high. Other things that came out of that survey is that almost 4/5 of all farmers, they practiced what is called thinning, which means that part of the flock is being moved out at an earlier age, and normally it's about 20% of the group that is removed at an earlier age, when they are on average 35 days of age, when they weigh only 2 kilograms. The genotype that is used mostly in my country is the Ross genotype, followed by the Cobb and then some other types of breeds. The vast majority use mixed sex flocks, and also the majority uses a dimming lighting system in which there is a transition period between dark and the light phase. Of course, these characteristics may differ in other countries, but I do think that the Flemish broiler production is quite representative for the majority of broiler production in the EU. So the conventional production column starts with the breeder pullet rearing, and they then produce the broiler breeders, which lay the eggs, which go to the hatchery, and these are then incubated for 18 days. Then they are transferred and candled, and then between incubation day 18 and 21, the hatching occurs. And these day-old chicks are then transported to the broiler farm, and when they are about 42 days old, they will be ready for slaughter. They will be caught and then transported mostly by trucks to the poultry slaughterhouse, where and after that there will be further partitioning, processing and trading. So that's the traditional production column. One welfare problematic area that is receiving more and more attention nowadays is this wide hatching window, because there can be approximately 30 hours between the chick that hatches first and the chick that hatches last. And before these chicks then actually arrive at the farm after transport, almost 5% of their life has already been passed. And during that time, they have no access to food or water. At least mostly so. In most incubator and hatcheries, they don't have an immediate access to water or food. And this has some welfare implications and also performance implications, because studies have shown that if they have no access to feed or water during the first 24 hours, they lose about 8% of their body weight. And such delayed feeding also affects their immune system in a negative way, also the gastrointestinal system, but also the amount of pectoral muscle they have in the end, and their ability to thermoregulate. Because of that welfare issue, several companies have started in looking into another way of producing broiler chickens, in which at the hatchery, it's actually incubated eggs that are being transported to the broiler farm instead of the day-old chickens. And then they hatch out on the broiler farm instead of the hatchery. So the transport is not on day-old chicks, but is on incubated eggs. And that has the advantage, of course, that these chicks then hatch on the farm, where they have immediate access to feed and water. Some studies have shown that the hatching percentage can even be higher than in the hatcheries, and that the chick mortality during the first week can be lower. And they tend to be also slightly more efficient in their growth, so that they are 1 day sooner ready for slaughter. A disadvantage perhaps is that because the barn is already occupied with the incubated eggs where they hatch, that means that the total duration that the barn is occupied per cycle or per flock is longer, meaning that the farmer can have fewer production rounds per year than is possible with the other conventional system. So this is some illustrations of this patio system of Vencomatic in the Netherlands, which is a very modern housing system for broilers, but at the same time also very intensive production system, in which broilers are housed in flats in different tiers, so that the three-dimensional space of a barn is fully utilized. And then here you see how the incubated eggs are brought into these kind of tiers, and where they hatch, and then when the chicks hatch, they fall onto the litter. And what you also see here, but is not clearly illustrated, is that they are actually housed on transport belts. And so at the end of the production round, they are not being caught or harvested manually, but simply this transport belt is the way that the chickens are being removed when they are ready for slaughter. If you want to see more of that, there's a link on a YouTube video clip illustrating this system. Let's turn now to enrichment for broilers. It is often said that there are very few possibilities to enrich the environment for broiler chickens. They tend to be very passive animal, not interacting a lot with enrichment. But some studies have investigated types of enrichment that truly benefit broilers as well. In this study, which was on a slower breed of broiler chickens, they compared several enrichment objects that were placed on commercial farms. So the first type they investigated was these kind of either alfalfa or straw hay bales that were on a heightened plateau, so they could get underneath, but they could also get on top of it, and they could peck at the straw or the alfalfa. So it's something that accommodates resting and pecking behavior. Another type they investigated were hanging objects which they could peck at, like here. And then yet another one was these kind of platforms in which the broilers could rest and also go underneath, or perches that they again could go on or underneath. So what they saw is that they actually observed more packing behavior directed towards the straw bales rather than the specific packing objects. And they also saw in the study that the use of the platform was much greater than the use of the perch. Another results they had is that the actual number of birds that were on the enrichment differed a lot between, for example, platform and perches or the straw bales. And actually the use of the platform increased as the birds aged and then kind of peaked when they were 6 to 8 weeks old. But also the area underneath these kind of enrichment, underneath the platforms and the straw bales and or the perches were used a lot. And they did that almost throughout their lives. And they were used a lot, which seems to indicate that also a darker place where they could seek shelter or hide seems to be quite attractive for broilers. So I turn now to the topic of litter and contact dermatitis, because the quality of the litter on which the broilers live has a big impact on the likelihood of them having footbed lesions. And the main type of lesions they suffer from, if the litter quality is bad or poor, is contact dermatitis. And that is mainly expressed on the middle footpad, but can also occur on the toes, in which you can see a darker coloration of the skin, and it can also lead to deep necrotic lesions, and which are quite painful to the animal. So one thing that a farmer can do to keep an eye on preventing the litter quality from turning too bad too soon is to check whether the manure of the chickens is of the right consistency and not too wet. And in order to do that, there exists something that is called a manure box, on which then the chickens will go and sit and defecate, and then you can inspect the type of defecations and droppings by lifting that box or watching through it. Another strategy that can be helpful is to encourage the scratching and the foraging behavior by the chickens, because that will loosen up the litter, which facilitates the drying of the litter and keeps it kind of dry. You can do that, for example, by scattering mealworms or something that the chickens like to forage for, which will increase activity, packing and scratching behavior, which will loosen up the litter. So it is often said that it's a multifactorial issue, the footbed dermatitis, and the same is with hockburns, which is a similar type of problem. And indeed, there are many, many risk factors that can increase the risk of footbed dermatitis, and these risk factors can relate to characteristics of the individual or the flock, such as the age and the weight, the genetics, the stocking density, whether they are ill or healthy, how much feed and water they consume, whether thinning practices is practiced. Also the gender, we see less problems among roosters than among hens, for example, but also a lot of environmental risk factors that relate to the housing and the management, such as the litter type, the litter quantity, how the litter is being managed, characteristics of the feed, the ventilation and the climate control control system. The season has an effect, the drinkers, and certainly leakage or spillage from drinkers is a very important factor that can affect the litter quality. Also, whether they have an outdoor run and whether the outdoor run is dry or not dry. The lighting system seems to have a role. Also, the practices that are being taken to control diseases, and also the provision of antibiotics, whether perches are present, and so on and so on. So there's multiple risk factors that can affect the prevalence of footbed dermatitis. Is this prevalence high? Yes, it can be very high. Here's some data from farms we investigated in Belgium. It's already 10 years ago, and it's only 10 flocks. But for these 10 flocks at least, almost 2/3 of the chickens were observed to have either a severity score of 3 or 4 for their foot pad lesions. So it's a very, very common problem in broiler production, also in farms in Belgium. A couple of years earlier, we used a different type of scale, not a 5-point scale, but a 3-point scale. But also, and we had on different 10 farms more or less the same prevalence, with 71% of the broilers having severe footpad dermatitis, which is known to be painful to the animals. It is often said as well that the welfare status of broiler chickens in the EU is higher than in many other parts of the world where they have less strict animal welfare regulation than we have in the EU. But perhaps that assumption has not been fully tested and should be tested much more. But there is actually very little data and studies that have been conducted that investigate this. And one, although very small study that has investigated this, they investigated also 10 flocks in Brazil, but these were flocks that were meant for the EU market. And these results are quite an eye-opener, because they clearly show that the problem of footpad dermatitis was actually much less of a problem in Brazil than in the Belgian farms that were investigated. And you can see the percentage of chickens with severe dermatitis in Brazil was much lower than those on our farms in Belgium. But also within the EU, there can be huge differences between one country and another. And here are some data from the Netherlands with many more flocks that had been investigated, where you see that the prevalence of chickens with severe footpad dermatitis is much lower than in Belgium. And I will explain later what a likely reason for that can be. So what's the remedy? What can we do against footpad lesions? Well, I think the answer to that question has already been shown by countries such as Sweden and Denmark and the Netherlands, in which they have put in place a system of mandatory scoring of every flock that goes to the slaughterhouse, in which, and for per flock, at least 100 legs, more or less randomly divided from that flock, are being assessed by a trained inspector or by an automated system. And these are scored for footpad dermatitis. And there's even a whole classification system in which that all of these footpads are being assessed for footpad dermatitis in a 3-point scale, going from no lesions, which is the score 0, mild lesions, a score 1, or severe lesions, which is a score 2. And then, depending on the severity of the lesion, they get a weighing factor, in which a severe lesion gets a weighing factor of 2, a mild lesion of 0.5, and no lesion of 0. And then when all 100 legs have been scored, you can allocate a flock score by multiplying the weighing factor with the prevalence of scores 1 and multiplying the weighing factor of 2 to all the prevalences of score 2, and then you get a flock score going from 0 to the maximum and the worst situation of 200. And the farmer then receives feedback about the score he gets for his flock. And if the score is too bad, meaning the score is too high, he can be urged to take actions in order to reduce the prevalence of footpad lesions in the next round. And so they, and for example, in Sweden, if there's once a flock score above 40 but below 80, they will receive some advice on how to better manage the footpad lesions problem. and they may even be asked to reduce the stocking density. If the problem persists, they will be asked to reduce the stocking density. And these strategies have shown to be very, very effective in reducing the prevalence of footbed dermatitis. Here are some examples from that. So you can see data from Sweden here with the prevalence of severe footbed dermatitis between 1994 and 2006. And 1994 was the date when they started with the mandatory assessment of the footbed lesions at the slaughterhouse. And you can see how effective that was and how quick the prevalence was reduced simply by having this mandatory checking. But of course, monitoring by itself is not enough. Also, there have to be consequences if the score is not good enough. A similar graph from Denmark, where the mandatory assessing or monitoring started in 2002, and here you see again how quickly the problem of very high prevalence of footbed dermatitis was under control after a couple of years running this mandatory monitoring. Take note that this y-axis scale is on a logarithmic scale, so what you see here, it does not do full justice by the speed by which the prevalence was reduced. Hogburns are a very similar problem of contact dermatitis, but not on the footpads, but on the hogs. And there's also scoring scales that are being used to score the severity of hog burns. Here are some data from Belgium again on the prevalence of these hog burn lesions according to each severity class, and then again compared to Brazil. You can see that it's not clear that Belgian farms are doing better than Brazilian farms. And another related problem is breast dermatitis, which you can have also very visible at the slaughterhouse, is severe dermatitis on the breast area. So the risk factors for dermatitis of the hog and the breast are for a large extent exactly the same as for footbed dermatitis, but there is one very important additional one on top of that, and that is to do with the ability of the animals to avoid contact between their hocks and breast and the wet litter. And that relates to things such as their leg health, the weight, whether they are diseased or not, and so on. So what do I recommend regarding remedying contact dermatitis? Well, the main causal factor of contact dermatitis, be it on the footpad or the hog burns or the breast, is the quality of the litter. And so it is known that at least severe contact dermatitis is painful to the animal and reduces their freedom of movement. It is an important welfare problem, but also economical problem. So it is worthwhile to monitor or to put a system in place for monitoring the prevalence of contact dermatitis, and it can be done very efficiently at the slaughterhouse, as shown in Sweden, Denmark, and Netherlands, for example. If the level of contact dermatitis turns out to be too high, and as illustrated by or as shown by the monitoring, the farmers should be encouraged to take actions to improve the situation by all these kind of management risk factors that affect litter quality. And they relate, and we've covered them: nutrition, drinking, ventilation system, and so on. And is it important to do so economically? Yes, because many of these contact dermatitis probably also have an effect on the quality of the carcass, the likelihood of carcasses being rejected for human consumption at the slaughterhouse, and if the feet of the broilers have a lot of contact dermatitis, there will not be able to sell them. And there is actually quite a big market for the feet of the broiler chickens in Asia mainly, but the market is not available to them if the problem of contact dermatitis is too bad. Are there other economical consequences of contact dermatitis? Probably yes, but it's not been investigated so well. But certainly if the animals are more reluctant to move because it's painful for them to move and to walk, it will affect, we can predict that, the drinking and eating times. And that may eventually also affect their growth. So let's now turn to the last topic, the topic of lighting. I want to cover that because it is known that the vision of broilers is very different from the vision of humans. And that kind of knowledge is only slowly starting to have implications on the way of how we provide lighting systems in broiler barns. So what is so different about the vision of chickens is that they have 5 types of light sensitive cells, whereas we as humans have only 3. So the ones we have in common with the chicken are the blue and the green and the red, but the chicken has additional ones for violet and ultraviolet. So they can see part of the ultraviolet, and they can also see part of the infrared, which are colors that are hardly or not visible to us as humans. And this implies that they perceive the light intensity of different colors quite differently. And both, especially at the short wavelength and the long wavelength. So at a short wavelength, like we are in the ultraviolet and the violet and the blue, they perceive that much more intensely than we do as humans. The green and the yellow we perceive more or less equally, but then again, when we go to the long wavelength, like the red colors and the infrared, they perceive it much more intensely than we do as humans. And that means that the kind of light and luminance unit that we use, the lux, is actually not very appropriate for a chicken. And that's why we really should, when we think about lighting systems for chickens and light intensity, we should use a conversion factor for the lux to the Galilux term. And so it's also the case that chickens then also see more colors than we do as humans, and that has a lot of implications that are hard for us to grasp and to understand and to take into account. And here's an example of a bird in which we as humans don't see gender differences. We don't see the difference between the male and the female, and it simply looks like a black bird to us. But with the eyes of a bird, of a chicken, there will be very big gender differences. And actually the male of this bird will be very colorful with the eyes of a chicken. And also with birds that we perceive as simply white, feathered, there may be some color marks that are visible to the birds but not to us. And these color marks might be very important for individual recognizing each other. But for that, ultraviolet light is needed. Otherwise, it's also not visible to the other chickens. And it has been shown in various research studies that if you add ultraviolet component to the light, it will have several effects. For example, what has been shown that for broiler parents, that they will that their mating behavior will be different if UV light is present. For example, they will spend more time inspecting each other before they actually start to mount each other. Also, corticosterone levels as an indicator of stress has been shown to be lower when UV light is present. The plumage condition has been shown to be better. They have been shown to be less fearful with the tonic immobility test. And some studies have also shown that they are less lame. So it's important to think well about appropriate lighting systems for barns for chickens. And a good kind of general assumption would be that natural daylight, or at least natural daylight in a rather dense vegetation, is what chickens are adapted to evolutionary, and that probably would be good light conditions for them. So trying to approximate daylight is probably a good starting point for thinking and adapting the lighting systems to chickens. But what we have is our conventional light bulb, and that actually doesn't reflect daylight very well and is really tailored to human vision rather than chicken vision. And the same with what we call the compact fluorescent lamps that are also often used. You can see a lot of gaps here in the wavelength, so they don't represent daylight very well either. So LED lights, more modern LED lights, you see that there's much less of these gaps here and more continuous scale of all wavelengths, so that's already much better. And then you can have even specialized lighting systems for chickens that try to accommodate and match better also the light sensitivities of chickens. And there's even a lighting company that has specialized lighting systems for chickens, in which it's based on LED lights, in which also by dimming the light, the color palette can be changed. And that can have interesting applications because if the full light spectrum is on, so there's no dimming, that would be the perfect light during brooding. So ideal to stimulate growth in the early development. And then it can be dimmed to something like 50% during the grow out. And that would be a more suitable lighting mixture for stimulating the muscle growth, because there's a lot of blue and green light, and the red is being removed, is less prevalent, because the red induces locomotion, and you don't want that if you want the birds to grow very efficiently. And then there's even, when the lamps are being fully dimmed, there's only monochromatic blue light reflecting moonlight, which is known to help to calm the chickens and to reduce aggression, and that is the light you want if, for example, if you want to catch them to be transported. Previously in the EU, and probably still the case in many countries outside the EU, broilers are often housed under a very long light period, sometimes up to 23 hours a day. And that often is of a low intensity. And that kind of lighting regime is applied because it increases their feed uptake and reduces their general activity, and both are beneficial for making them grow efficiently. And having the light at a low intensity and not a high intensity also means that you could be saving on the energy costs for the lighting. But such lighting systems have been shown to have adverse effects for the behavior and the welfare of the animals. So it can disturb their diurnal rhythms, their synchronization, their activity levels, which are then related to a higher risk of leg problems. They are more disturbed of rest during the dark phase, the short dark phase that they then have, and you see less preening and foraging behaviors, which are important behaviors for chickens, and also an increased mortality. That's why the EU has since 2007 welfare legislation that also give details about the lighting system, in which it is stated that they need to have at least 6 hours of darkness per day, of which there needs to be a continuous dark period of at least 4 hours, with the exception of the first week of the broiler's life and the last 3 days before slaughter. So then a kind of continuous light period is actually still allowed. And the light period, during the light period, the light intensity has to be at least 20 lux for at least 80% of the usable area for the chickens. You will already know by now that I have my suspicions about the appropriateness of 20 lux, what that means really for a chicken. So ideally it should be expressed in gallilux. We at the moment have also a research project ongoing in which we are investigating which light colors broilers actually prefer themselves, depending on which activity they are performing. And these results are hot off the press. They haven't been published yet, so I can kind of give you a preview of what the results are from this study. So the objectives of the study was to evaluate light color preferences by broiler chickens for feeding, drinking, resting, and scratching, and additionally to investigate if they show preferences, whether they are affected by the age of the animal, by the provision of enrichment, in this case platforms, or by heat stress. So we did this experiment at the ILVO Institute, where we had 4 pens available, divided in 2 compartments. And both compartments had their own climate control system, so we could induce heat stress in one compartment and no heat stress in the other compartment. And in each compartment there were 2 pens. Always in one pen we could provide platforms, and then the other pen was the control one without a platform, and the same for the heat stress compartment, one pen without platforms and the other one with platforms. Yeah. And then we replicated that study in 4 different rounds, in which the presence of the platform and the induction of heat stress was balanced over the different pens in the study. And then we divided each pen in 4 functional zones. So there was where the eating line was, the feeder, there was a drinking line, there was the area for resting where the platforms were, and there was a scratching area behind that. And what we did is for each functional zone, we provided different types of light that were chosen by the company, the light company we collaborated with, Explorantis. So they chose 3 different lighting colors per functional zone. And then we used video surveillance in order to analyze the results and to look at the preference and which area or light color they would prefer for which activity. And of course, and this was nicely balanced again, so that each light position was occurring was changed between different rounds. And so these are the camera images that we obtained. And then we used image analysis, kind of homemade image analysis system to automatically record the occupancy of the different lighted zones. So what you can see here is the drinker line, is the feeder line, there's a drinker line, this is the platform line, and behind that is the scratching area. So what are the results? So we found indeed that in the drinking zone, they expressed a preference. They actually preferred the reference white light above the 2 other ones, the yellow and the cyan. But there was no effect of the platforms. In the grower phase, they actually preferred, again, the white to the cyan, but again, no effects of platforms. And during the finisher phase, there was an additional possible effect of heat stress. So we have the platform with heat stress, platforms without heat stress, and we got control groups with heat stress and control groups without heat stress. And we saw in the finisher phase that they actually avoid cyan to the other light colors, but there was no effect of heat stress or platforms. For the starter phase, for the feeding zone, during the starter phase, we see that they avoid the red color, but again, no effect of platforms. For the grower period, there were no statistically significant differences. And for the finisher phase, we saw that there was quite a pronounced preference for cyan now, but no effect again of heat stress or platforms. Let's move to the resting zone now, where the platforms were. And there we see that they prefer the cold white to the warm white, and there's no effect of platforms. For the grower phase, they have quite a pronounced preference for cold white, and again at the finisher phase, but no effects of heat stress or platforms. And then the last and the fourth zone was a scratching zone. We found there no statistical preference for one color or the other. We simply noticed that the scratching zone was used more if there was a platform present than in the control groups. The same for the grower phase, no color preferences, and the same for the finisher phase, no significant preferences. So what we conclude is that the light preferences can differ per functional zone. For example, they prefer cyan for feeding, but not at all for drinking. Some light preferences also change as the birds age. And thirdly, the light color seems to be quite robust to changes in the environmental conditions. So they were not or hardly affected by enrichment or heat stress. What now this research tells us about how lighting systems in barns, which color should they provide in commercial barns, cannot yet be said from this study. We don't know yet what the effects would be if we gave them their preferred light for each zone compared to the standard light. So we need to do kind of a follow-up longitudinal study in order to investigate these effects.